To make the random walk example a bit more lively, let's consider a different perspective on that. So take a situation where we are observing a drunk man. He had a very nice night out, but he drank a bit too much, and now he has difficulty getting home. So while walking home, he has to cross a square. But he cannot walk straight anymore because he's too drunk for that. Now, this is a process that we can think of in terms of a random walk. Well, first, maybe he's not very drunk. Well, in that case, even if he doesn't walk straight, he walks to the side, but he will see that he's actually going in the wrong direction and he can correct for that. This is what we call mean reversion. So he can go back to the path he was actually supposed to take. But if he's very, very drunk, then he will not be able to correct anymore because he does not see anymore actually where he should be going. And every step he randomly could go off to the left or off to the right. Now this is one form again of a random walk. It's essentially before every step he's tossing a coin and then based on the outcome going either left or right. And it turns out that there's no guarantee that he's actually coming back to the right direction. So if you look at that graphically, well, the man is starting here and he has to cross this nice square. He has to go here. In a straight line, it would be the blue line. So if you were sober, you could just walk straight on the blue line. Now imagine that he is a bit drunk, so he cannot really stick to the blue line, so he moves off. But then he realizes that actually, no, this is the wrong direction, he should be going more here. So he corrects for that and goes back to the blue line. Well, he cannot stay there because, again, he strays from the line but moves back again. And this process keeps on going, so he's walking too much. But in the end, he will end up around the point where he should end up. So he'll get home safely. Well, let's now look at the situation where he actually is very drunk. So the only thing he does is randomly either move to the left or move to the right. And he should hope that he ends up in the right place. So here I simulated that exactly using the coin toss example that I showed in the previous video. I simulated this in R and, well, in this case, he wanders off quite a bit and then he has a lucky turn and he moves back and he moves back, but of course he doesn't stay there and he moves further. Well, here he's quite lucky because he will still end up somewhere in the reasonable place. But it might just as well have gone like this. He wanders off, and he never comes back, and he ends up on the wrong side of the square. And then he just has to hope that he can still find his home from there. Now what you can see, if you look at this purely as a time series, is that there's a clear trending pattern. But the trend sort of drifts off. And this is the nature of a stochastic trend. It could go anywhere. It could go here, where it first goes up and then down, but it could also go there, and it could go anywhere. And this is the reason why this mechanism of stochastic trend, here illustrated via the random walk, can give you such differently looking trends in data.